Hello, all. Welcome to week 4. I hope that everyone is having a good week and that you're prepared for the midterm examination. So, this week we're going to look, chapter 7 is going to be inventory management. And as I've stated earlier in the course, inventory management really is a key tenet of what supply chain and procurement can bring to the organization. When you consider the value that we bring by managing the strategic allocation of the financial resources, part of that is making sure that we're identifying the inventory that turns, the inventory that brings value, and really making sure that we're putting inventory on the shelf that is going to provide a financial return on our investment. So, through this chapter, some of the learning objectives, we want you to be able to distinguish between independent and dependent demand inventories, describe the 4 basic types of inventories and their functions, to be able to articulate the cost of inventory and inventory turnovers, and understand the ABC classification, inventory matrix, and cycle counting. So, when we jump into um, and start looking at inventory, really it can be one of the most expensive assets that an organization has. And supply chain management really needs to strive to reduce inventory levels, but still avoid running out of material. So you want to make sure that you have enough material to meet demand, but not so much that you're tying resources up in it. You need to understand the shelf life of your inventory. So this, if you're working maybe in retail or even in food production, this obviously can be a major part. But what you may not realize is that in industrial production, things that use rubber or corrosive items, this can also be needs to be considered. And then when you look at inventory, more is not always better. If you have excessive amounts of inventory, you run the risk of obsolescence, you run the risk of wasting company resources, and it's really a sign of improper management of your inventory. Um, and it can definitely adversely impact the financial performance of your organization. So, when we look at dependent versus independent dependent demand is internal demand for parts based on demand of the final product in which parts are used. So subassemblies, components, raw materials, I mean, these are all dependent on what's being made. So, if you're building a car, the wheels, the tires, the car seats, the steering wheel, the headlights, those are all dependent demand. Whereas independent demand, it's the demand for the end products and has demand pattern affected by the trends, seasonal patterns. So the car itself could be the independent demand. More people are probably going to buy convertibles in the summer than they are in the winter. So some concepts of inventory management that we need to consider: buffer. So primary functions of inventory are to buffer from uncertainty in the marketplace. So that's having some kind of safety stock. So you want to have enough, but not too much. And the decoupling of discrepancies in the supply chain. So, like we said, having that buffer, having that safety stock to protect against those discrepancies. You have 4 broad categories of inventory: raw material. So this is um, the very rawest form. If you're making plastic bottles for Coca-Cola, this is the resin that would make the plastic bottle. The work in progress. So this is partially processed material. So this could be the bottle after it's formed, but before it has the lid and the label. And then the finished good is when it has the lid and the label on it. And then the fourth form is MRO, which stands for maintenance, repair, and operation. And that's everything used to make the plant produce the product. So that's cleaning supplies, PPE, which I'm sure you've heard so much about due to our current climate. It's everything from toilet paper to the lubricants that run the machines to the spare parts. So some concepts, that when we look at, further the context, when we look at some of the ways that inventory cost is put together, what are the direct costs? So these are directly traceable to a unit that's produced. So, when you are inventorying a finished good, you have to include all the components, but you also have to include the overhead. You have to include the labor that went into producing it. And then there's an indirect cost, so costs that cannot be traced. So, the variable overhead. Would be a direct cost, whereas the fixed overhead would be an indirect cost, because it's when you're looking at the plant or you're looking at the capex itself versus the variable overhead, which is directly tied to production levels. So fixed cost, those are going to be independent of the output quantity. So, like we said earlier, buildings and equipment. Variable cost, that's going to be your materials. It could also be the utilities needed to produce your products. Order costs, so that's your administrative costs for placing an order, placing a PO, receiving, holding and carrying. So that's what's the cost for inventorying it, what's the cost for storage. So if you look at it that um, as an organization, you're going to charge the supply chain for square footage used to store material. That's part of your holding cost. Um, your carrying cost is the cost that the organization would then charge you for using organizational resources. So that's almost like an opportunity cost. So if you consider, um, let's say the bank were, or let's say your company were to invest $10,000 in inventory, but if you were to put that $10,000 in a CD at the bank and could get 3%. Honestly, the business is going to want to charge you 3% to make up for their opportunity for their lost cost. And then you want to consider your setup cost as a component of your inventory cost. So, and the setup cost is what it costs. So if it costs 100 man hours to set up a machine to run a product, and your internal rate for man hours is $10 an hour, then you look at that as $1,000 in setup fee. That is then divided out over everything you produce during as a result of that setup. So the inventory investment, the way you measure it is you can measure the absolute value of the inventory. So what do you value the inventory at, and then how does it look on your balance sheet? Cycle counting is a way that you physically count your inventory on a periodic basis. So when you conduct a cycle count, you don't count every single thing in your warehouse, but a best practice is to cycle count every day, and you can randomly generate X amount of items, usually 10 to 20% of your SKUs, and you go out and you count them and you verify, and that can signal that if you have a systematic error in your inventory system. And then inventory turnover and turnover ratio. You want to look at how much your inventory is turning, how much you're using it. You want the inventory turn ratio. The formula is going to be cost of revenue divided by the average inventory, and you want that to be high. You want your inventory to turn. Um, so when we look at the ABC inventory control system, you're always going to bucket your inventory into A, B, and C. So the A items are given the highest priority with larger safety stocks. A items usually account for 20% of the total items, but they're 80% of the total inventory, 80% of the total turns. B items are going to account for 40%, and typically it's about 15% of the inventory cost. So 40% of the total items return and 15% of the inventory. And then C, these are low value, low priority. They account for 40% of the total items, 5% of the total inventory cost. So, if you were to look in your pantry, the for example, something like cereal or oatmeal, it gets eaten every day. You buy it all the time. That might be an A item. A B item might be something like potato chips or pretzels, where you maybe eat them twice a week. And that C item is going to be like your spices. It's going to be things that you don't use that often. Um, Concepts. So there is a matrix in the text. I'd recommend you look at it. It really helps you understand how to balance your A, B, and C items. So furthering the discussion on inventory, so the text also talks about near field communication. So this is a secure form of data exchange between the NFC or near field communication tag and Android power devices. So it's utilizing two major RFID standards. So it does have an electronic product code standard that's managed by EPC Global. It's an outside software you can purchase, and it is managed by the 18,000 standard from ISO, which is the International Standards Organization. And you can set your RFID tags to classify 0, 1, 2, 3, 4. and then class 5 tags can communicate with other class 5 tags. So it's really just a good way of tracking your inventory. And then moving on, so when you start to look at your inventory decision making, data is really going to be a huge part of how you make your decisions. So you're going to hear the term, and the text talks about it a little bit, but big data. So big data is gonna refer to the collections of data sets that are too large, too complex to be processed by a traditional database, and that's oftentimes when you're going to use a bolt-on function to your ERP. For example, my company uses we use an outside tool called Power BI, where we can pull data in from SAP, and then we can use Power BI to manipulate it and put it in an easily readable process. Big data technology, it's really growing. It's going to be a key component of supply chain. It's something that I've looked at writing my dissertation on is preparing undergrad curriculum to be prepared to work within automated big data and artificial intelligence. So while big data is it's key, I mean, supply chain is becoming such a more data-driven function. More and more of that big data, though, is being automated. So it's more of a understanding of how to interpret it once you have it and how to use it to make strategic decisions and how to use it to act and bring the utmost value for your organization. So some inventory models. The first one the text talks about is a fixed order quantity model. Or sets of fixed order quantity models. So that's the economic order quantity model, that's the quantity discount model, and that's the economic manufacturing quantity model. These models are going to use fixed parameters that help you determine what the optimum order quantity is that really is going to minimize your total inventory cost while maximizing your positive impact on the organization. So the first one is economic order quantity. The text will shorten that to EOQ model, but it is a quantitative. So when we talk about statistics, there's quantitative and qualitative. So remember, quantitative is more fact-based, qualitative is more opinion-based. Um, I always like to remember that quantitative is quantity, qualitative is quality, and when you're using a qualitative decision model, you want to make sure that the opinion you're using is a high quality opinion. Just a little trick I've used to remember it. But it's a quantitative decision model that's based on, we have trade-offs between annual inventory holding cost and annual order cost, and it's seeking to determine kind of what's that optimal order quantity, and it's also going to take into account what's the order cost. Order cost is a direct variable cost. It's directly associated with placing the order. It can be called the setup cost. It can be called an administrative cost, and then it also takes into account what's the holding cost. So what is the cost that the organization bears for holding inventory? So oftentimes, commonly, you're going to hear finance and accounting call that a carrying cost, but that is, what is the organization charging you for square footage, for shelf space to hold it? What are they charging you as a return on investment? What do you have to turn that in order to generate the amount of profit that that money would have had invested in other avenues of growth? Um, so when we look at the EOQ model, there's going to be some assumptions that must be made. So the demand must be known, it must be constant. Order lead time must be known, must be constant. So we must know, we're going to use 10,000 pins a month. We know that when we order the pin, it's going to take 2 weeks to get in. We have to know it, it has to be constant, it has to be predictable. The replenishment has to be instantaneous. It has to use almost a Kanban system to where we know that we're going to use those 2,000 pins a month, and we know that it's a 2-week lead time. So when we hit 1,000 pins, we're placing another order, because by the time the order comes in after 2 weeks, that 1,000 pins that was in inventory is going to be gone, and we're going to be ready. Um, and then the price has to be constant. It helps with understanding how it's going to impact the budget, what the carrying costs are going to be, what the financial risk to the organization is. And as a result of that, like I said, what's the carrying cost? What's the ordering cost? Stockouts are not allowed, so you have to have a minimum order quantity. You have to have an order point, and when you hit your order point, you order, and it's a constant replenishment of inventory. Um, So the next model is the quantity discount model or a price break model, and it relaxes the constant price assumption by allowing purchase quantity discounts. So in theory, if you know you're going to use 2,000 pens a month, but if you know if you order 2,500, you get a 10% discount, you may order to gather that discount, because at that point it's going to have a greater financial impact of your organization. You're buying at a lower cost, so one of two things can happen. You can sell it at a lower cost, which then you sell more pins, you generate more revenue, more profit that way, or you sell it at the same cost and you just make a greater profit. So this does consider what are the trade-offs between purchasing in larger quantities to take advantage of the price discount, and the higher cost of holding the inventory. So that is something that, even though you may be buying the pin 10% less, if it's 5% more to hold it, your true benefit may only be 5%. I'm simplifying that formula. There is a time cost of money. Yeah, as supply chain experts, always know those numbers, but always have finance calculate them. Um, and then you know, by doing this, by knowing that return, by working with finance, you can determine at what price break. So you may get the discount at 2,500, but the additional profit may not be worth it until you hit 3,000 pins. And then looking at economic manufacturing quantity model, or it's also called the production order quantity model. So this is going to relax the instantaneous replenishment requirement. So it's going to relax that I hit 2,000, or I hit 1,000. I know it takes 2 weeks to get my order back in. I'm going to order. So this, economic manufacturing quantity model is especially appropriate for a manufacturing environment with simultaneous manufacturing and consumption. And the inventory for this is going to build up gradually during the production period rather than all at once as in the EOQ model. So yeah, these inventory models it's really going to factor on what type of industry that you are practicing supply chain in, as far as the best one. And with any decision, supply chain should never make decisions in a vacuum. You should consult the business. Should consult your stakeholders. You always must know the statistical reorder point, which is what I had alluded to earlier. So, if you're buying something and you use 1,000 a month, and you know that it is a 3-week lead time, when you hit 1,500, you need to order again. So, you have to know your demand and you have to know your delivery. They have to be you have to be able to predict them. There has to be some stability. There has to be knowns and constants, and there has to be predictability to really have a valid reorder point. Because if your reorder point is set too low, you run the risk of stock out. But if your order point is set too high, you run the risk of excess inventory and really misallocating financial resources of the organization. So when you go into the text, there's some really really good diagrams and some really good further descriptions of a more formalized standard reorder point formula. I'm definitely simplifying it, but if you are interested in that, open up the text, look at some of the formulas, and I'm more than happy to have a conversation about how this applies in the real world. Also in inventory, there is a continuous review system model. So reality shows that stock records and actual quantity are different, and it requires a continuation review. So this takes into consideration that an organization is a living entity, that its customers are a living entity, that the demand always changes. So Ford may predict that it's going to sell 100,000 Ford Explorers this year. But it's not going to sell the same amount every month and every week. You're going to have peaks and valleys of auto sales. So having this continuous review can help adjust your inventories and adjust your ordering to fit those um, to fit the demand that's not evenly spread out throughout the year. Whereas a periodic review inventory system can also do that, but it's more, you may review it monthly, quarterly, whereas continuous review, you're constantly reviewing it. So once again, your inventory review model definitely depends on your organization's philosophy on investing in itself. It depends on your organization's tolerance for risk. Um, And there's some further definitions of that in the text. Just really some high-level simplification. As always with any of the material, if you're interested in discussing it further, learning more about it, I'm always available for a Zoom call. Or just exchange some emails. So I hope you guys found this interesting. I'll talk to you soon.